today we are discussing some type of functional completeness. Okay. So, exactly what is the meaning of functional completeness, and where we are using this particular concept, functional completeness. Okay. So functional completeness means what? If one particular given function is there, and different type of parameters, if we are using, how the parameters are actually covered all the completeness of that particular function. Okay. I'm requesting all of you, please, you can, if suppose if I am getting late, suppose you are not, you are unable to attend the meeting, but repeatedly you trying. Okay. But again, what when I have joined, again you have after a few minutes or again you are coming, then it is problem. Okay, I am getting disturbance, and this particular disturbance is occurred many times. So before I am starting the class, be ready from your side. See here, the basic concept. Actually, this particular completeness, we are using some particular operation. Okay, and when we are using that particular operation, you know what is Boolean function, what is Boolean algebraic expression. Okay, when talking about the Boolean algebraic expression, that time what happen, we are using some type of operation. But same thing, when we are applying or when we are designing the circuit, that particular operation is going to some particular gates. Gates is nothing but a operation in Boolean expression. Okay, so what happened? So because this particular subject, because yes, obviously Boolean expression is required to construct the circuit and all those things. But when we are going to the circuit, you have to know how this type of gates actually working. Okay. Before that, then how we can say that based on the Boolean expression, how we can say that which particular gates are functionally complete. Okay. So what when someone is asking you in digital circuit or in switching circuit or whatever, which particular gates are called basic gate? So here your answer is that the basic gates are generally not, and or. Not gate, and gate, and or. These all are the basic operation, and when we are applying this particular basic operation to the circuit, that time what happen? This particular operation is called a not gate, and the or gate. Are you getting my point? So what happen? Any Boolean expression can be realized using this three operation. What is the meaning? Meaning is that if we are any particular circuit, we have a tree operation, or suppose we have a three gates, not gate, and or gate, we can design any type of gates. Okay, so that is the beauty of this particular three gates. I'm talking about not only not gate, I'm not talking about not only and gate, the combination of not and or you can consider as this type of set. So here I'm writing this particular curly bracket. Okay, so what happened? So we can say that this particular tree operation, using this particular tree operation, we can build any circuit, or using this particular three gates, we are using any circuit. So not and or is called a functionally complete. Okay, so this second particular point is coming, this particular concept, first concept. Okay, so what happens? Suppose example, we are considering one particular function, and this particular function is defined by there are four variables A, B, C, D. Okay, and we are writing this particular expression. And see here, when we are converting to the gate, okay, that time what happens? This we are using not operation also, or not gate also. We are using or gate also. We are using the and gate also. So when we are using the tree operation, that time what happens? This particular expression is complete. And when we are going to design this particular expression to the circuit, that time what happens? Three gates are required. One is called a not gate, one is called a and gate, and one is called a or gate. Okay. Now what happen? We can implement the circuit using NOT and OR gates, because these are all are the 3 gates are functionally complete. Okay, so what happen? We can implement the circuit using this one is okay, this particular 2, this one is okay. Now see, this particular point is very important. Now what happen? Other set of gates can be also be shown to be a functionally complete. Suppose what happen? We have some particular gates other than this particular NOT and OR gate. We are using some other gates. Now, how you prove that the other gates are functionally complete? Okay, so that means what? If we are one particular gate, some particular gates we are considering, and after that anyhow we have to prove that that particular gate also implement NOT gate also, AND gate also, OR gate also. That time what happen? Obviously we can say that that particular gate is also functionally complete. But remember one thing, if suppose NOT gate is we can realize, AND gate also we can realize, but OR gate is not a it is not capable to realize. That time what happen? That particular gate is not a functionally complete. So any particular gate you have to prove this particular gate is functionally complete or not. That particular gate must be satisfied a NOT gate also, AND gate also, and OR gate also. Are you getting my point? Any doubt?
Sir, can you explain it again?
Yes, sir.
See here, NOT and OR. These are the basic gates. Okay. Now, why it is called a basic gates, or you can say operation. Don't confuse about the basic gate. Don't confuse about the gate and operation. When we are using the operation, when we are dealing with the Boolean expression. Okay. And when we are dealing with the circuit, that particular operation is moved to the gate. Rename is called a name as a gate. Okay. So what happened? Basic gates are means what? If we are using the basic gates, we can design any type of circuit. Any circuit. Are you getting my point? In digital circuit, so NOT and OR are the basic gate. Due to the fulfillment of property of basic gates, the set of the combination of NOT and OR, because this is the one particular set, we are including one particular set. So what happened? The set of gates is called a functionally complete. Okay. Now see here, if these particular 3 gates are called a functionally complete, that time what happen? If any other gates, if we prove that particular, suppose XYZ is, suppose X gate is functionally complete or not, that time what happen? You can prove by the help of that particular gate satisfy the NOT gate also, that particular gate also satisfy the AND gate also, and that particular gate also satisfy the OR gate also. Satisfy means what? That particular gate easily implement NOT gate, easily implement by the help of that particular gate, X gate, and also implement by the help of that particular X gate, and OR also can be, it is possible to implement with the help of X gate. So X gate is capable to implement NOT, also AND, and also OR. That time that particular X gate is also called a functionally complete. Are you getting my point? Now it is okay? Now it is okay?
Yes, sir.
Now whatever we are discussing, just we are going to this particular point. Now I am saying that NAND is functionally complete. How we can prove that NAND is functionally complete? Obviously, you know NAND gate is the universal gate. Universal gate means what? From NAND gate also we can design any type of circuit. But there is something difference between the universal gate and basic gate. If someone is asking you, NAND gate is a basic type of gate, no, your answer is no. Because when we are going to prove the functionally complete, we can prove that yes, this AND gate, OR gate, and NOT gate is the we can implement, because we know in digital circuit 3 gates are also called basic gates, that is AND gate, OR gate, and NOT gate. But NAND gate is why it is called a universal gate, because using the NAND gate we can also design any circuit. Yes, it is the similar. Also with the help of basic gates also we can design any type of circuit. Now what happened? Yes, this is the universal gate. Yes, we know universal gate means what? Because we can, suppose you can design one particular circuit with the help of AND gate, OR gate and NOT gate. Okay, that same circuit we can convert to the NAND gate. You can use only NAND gate instead of AND gate, OR gate and NOT gate. Instead of AND gate, OR gate and NOT gate, then also that particular circuit is satisfied that particular Boolean function. Okay, so what happen if any type of basic gates we can design with the help of NAND gate. So NAND gate is a universal gate. Now what happen? If NAND gate is a universal gate, obviously it is the functionally complete, because we have to follow the AND operation, we have to follow the OR operation, we have to follow the NOT operation. Now what happen? How you can prove that NAND gate is a functionally complete? Okay, so here it is mentioning that we can show that we can realize from the NOT gate, from the NAND gate, we can realize the NOT gate. From the NAND gate also we can realize the AND gate, and from the NAND gate also we can realize the OR gate. If we successfully prove this one, that time what happen? NAND gate is also called a functionally complete. Now you know how we can perform the NAND gate operation. NAND gate means what? It is the combination of NOT and AND gate. And non-AND gate is one type of NAND gate. Okay. So what happen? We are using when we are using the operation NAND gate. We are using the two variables a comma b. That time what happen? We are using the AND operation here. So dot means what? It is AND operation, and we are using the complement. So this one is what? It is the NOT operation. So NAND operation, how we can write? We can write a dot b with the complement. Okay. So what happened? Using NAND gate, how we can show that if we are using the NAND gate, then also it is equivalent to the NOT gate. Okay, see here, NOT means what? It is a complement. NOT means what? It is a complement. Okay, when NOT is a complement, then how we are using the NAND gate? Okay, suppose, see here, I am using this particular one. Suppose this is the AND gate. Sorry, it is the NAND gate. Is the symbol of NAND gate. Okay, and here using only one particular variable, I am using see here, I am using only a. Okay, so what happened? We can connect it with the two side. Suppose this is the connection between the two variables, or you can use any variables. So you know a dot a equal to a. So what happened here? What happened? This particular a dot a is performed here. And after that, what happened? This is the NAND gate. So we are using the complement. So a dot a equal to nothing but a bar. So we can successfully, using the NAND gate, we can successfully implement of NOT gate. That means we can implement the NOT gate using the NAND gate. Suppose AND gate, see here, AND gate, how we are using. Suppose AND gate means what? A dot B. That means A multiply with B. So how we can use the NAND gate? So see here one particular, suppose it is the we are using this one, and after that we are using this one. This is also NAND gate, and this one is and we are getting A dot B. A dot B. Okay, this one is call it A. This one is we can call it B. You wait for a few minutes, huh? Just I am coming. Just someone is calling me. Okay, you wait for a few minutes. No, few minutes. হ্যাঁ আছে কি আছে sorry all of you there
Yes, sir.
Hello?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
so see here so
Yes, sir. Yes, sir.
yes this particular diagram you are getting this particular diagram the meaning is that this one is what if we are considering this particular what is the output is A. Can you tell me what is the output? A dot and B. So A dot B is whole complement. We are using the whole complement. Are you getting my point? So whole complement, again what happened? This particular single line is connected in double line. That double line means what? It is actually it is the circuit design technique actually. So just we are because anyhow this is this particular gates we can converting to the some particular expression. Okay, and after that what happened? This one again we are going to complement. Whole thing we are going to complement here in this particular part. So this one equal to what? This one equal to AB. Okay, this one equal to AB. Okay, so see why we are writing here like that, because you know in the Boolean law of the Boolean, because if you are using some particular rules of Boolean expression, that time whatever you know this one a dot a whatever a dot a equal to what? A. Are you getting? No, this one. So meaning is same. So what happened here? A dot b bar and a dot b bar, a dot b whole complement dot a dot b whole complement equal to a dot b whole complement. Okay, so if we are manipulating only this particular part, okay, this particular part, that time what happened? We are getting only AB complement. And what happened? Outer side again we are using one particular complement. This one is the complement. So again what happened? Here we are using, this is the complement. So what happened when we are using the De Morgan's law? That time what happened? We are getting AB. How we are getting AB? We are not using any De Morgan's law. Sorry, we are using the double complement. So double complement means what? It is same. The answer is same. And similarly, see here A plus B. How we are using this particular expression? Similarly, we are using this particular expression like that. Suppose here I am using this one. Sorry, this one is the one NAND gate. Okay, and this one we are using another NAND gate. Okay, and here suppose here I am using this particular part. And here I am using also this one. Okay, this one is A, this one is B. Okay, and after that what happened? This one we can connect it to this one. We can connect it again NAND gate. Now see what happened? A plus B. So A plus B, what happened? This one is the A bar and this one is the B bar. Again, what happened? This particular connectivity shows that we can again breaking this particular A bar into two form, A dot A bar. Again, B bar, again we can breaking with the help of B dot B bar. B dot B whole bar, A dot A whole bar. So you know A dot A means what? A bar. B dot B means what? B. A dot A means what? A. B dot B means what? B. So A complement with B complement and whole complement, we are getting here A plus. Are you getting my point? So what happened? Here A complement, this one is the A complement. This one is the A complement dot B complement, and this is the whole bar. Whole bar. Whole bar means what? If we are applying the De Morgan's theorem, that time how we can simplify this particular expression? This particular expression we can simplify this way: A bar plus, because when we are using the product and then this particular and is converted to the plus. So here it is B bar. Here B bar, and A bar means what? A double complement means what? It is A, and B double complement means what? It is B. Are you getting my point? Okay, this way. So what happened? This particular NAND gate, we can successfully implement the NOT gate, AND gate, and OR gate. So we can say that though it is the universal gate, also we can say that NAND is a functionally complete. Okay. The similar way, NOR is is also functionally complete. And what is the how we can define the NOR gate? NOR means what? A comma B, and we can write A plus B, because we can use the NOR gate means what? It is the combination of NOT and OR gate. So you can just try this one. The similar, whatever we are discussing the last slide, we can also implement the NOT gate, and also we can implement the OR gate, AND gate and OR gate. You can try yourself how to design this. You can convert this particular expression to the circuit. Okay. Suppose first one is just I am showing the first one. First one is very simple. We are using A. We are using only one input. So what happened here? We are using this one. We are using this way. And we are using the OR operation, not a NAND operation. So this is the symbol of NOR gate. So this one is this one. So this one means what? This is the A bar. Are you getting my point? And second one, see, before we are going to the AND, OR is simple. So at first we are try for OR and we are going for. So how we can define the OR gate? So OR gate also, suppose here this one is A and B. We are using this one. If we are remember, if we are going to prove that NOR is a functionally complete, then when you are designing the circuit, you only use the NOR gate. You cannot use the other gates. Okay. With the help of NOR gate, you have to prove that if it is NOT gate, it can be implemented. AND gate also it can be implemented, and the OR gate also it can be implemented. Then we can say that NOR is a functionally complete. Okay. So this one we can prove. We can design this particular way, and after that way we can design this one. So this one means what? This one, it is the implement of OR gate. Okay, here A plus B whole bar. Again, what happen? We can break this particular A plus B. Okay, so because we are using the double connection here, and after that, what happen? When we are breaking this particular expression, that time what happen? Here we are getting the output is what? Output is A plus B. Now you can try for AND gate. It is similar manner. Okay, and this is the how to design the AND gate. It is the homework for you, and you can try yourself. Okay, any doubt? Then please ask me. Don't keep silence. It is not my duty. Then I'm speaking. Speaking. Why you are doing? You are not asking any question and all those things. Any doubt this one?
No, sir. Yes, sir.
Now what happened? Again, what happened? Yes. Obviously, what happened? NOR is functionally complete and NAND gate is functionally complete. Okay, no problem. Now what happened? How you can prove that? We can also AND and NOT is a one type of set. The combination of AND and NOT also it is called a functionally complete. Okay. So what happened? We have already know that NAND is functionally complete. Okay, because we have already proved that NAND gate is functionally complete. Now what happened? NAND gate we can easily realize by the combination of AND gate and NOT gate. Okay, so NAND gate we can realize as an AND followed by a NOT gate. For that particular purpose, we can say that AND and the combination of NOT is also functionally complete. Okay, hence we can say that AND and NOT is also functionally complete. Because you know why it is this one. Suppose if we are designing some particular circuit like that, this is the AND gate. This is the AND gate. Suppose if we are using after that, if we are using NOT gate here. Okay, if here this is the symbol of NOT gate. So this one is equivalent to this particular circuit. Just a minute. So this particular gate is equivalent to the NAND gate. Okay. So what happened here? We are using AND gate. This one is the AND gate, and here we are using the NOT gate. And when we are combining AND gate and NOT gate, it is forming the NAND gate. And already we proved that NAND gate is the functionally complete. And NAND gate is constructed with the help of AND gate and NOT gate. So we can say that and the combination of AND and NOT gate is also functionally complete. Are you getting now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
The next one is similar fashion or comma not. Or comma not is also functionally complete. Why? Because what when NOR gate, how we are designing the NOR gate, because this one is suppose this one is the OR gate. Okay. This one is the OR gate. And after that, what when we can use one particular NOT gate. This is the symbol of NOT gate. This is the symbol of NOT gate. So this way we can form the NOR gate. We can form this is the symbol of NOR gate, and this one we are using two particular inputs. Suppose we are considering here also we are considering two particular input. Okay, those two particular input we are considering. So what happened? Already we proved that NOR gate is already functionally complete. Our earlier slide from the earlier slide. So and the NOR gate is constructed with the help of OR and NOT gate. So also we can say that OR NOT gate, the combination of OR comma NOT is a functionally complete. This particular set of gate is functionally complete. Okay. Now what happened? Again, we can see one particular combination of this one and XOR comma 1 is also functionally complete. See here AND gate and OR gate also functionally complete, but we cannot only use AND and XOR gate. We are using some particular value, constant binary value, it is 1. If it is 1 is combined with the XOR and AND gate, suppose whatever, sorry, 1 is combined with the XOR gate, that time what happened? We can say that the combination of AND, XOR, 1 is functionally complete. But remember, without AND, XOR, 1 is not a functionally complete. So XOR means what? XOR means it is, we can define the symbol is like that in Boolean expression. Okay, and how we can prove that AND comma, yeah, this one, AND comma XOR comma 1 is functionally complete. See here, when we are writing A comma B, if we are defining this particular operation, that time what happened? The expression is something like that. How? You know already this one is the A, this one is the B, suppose this one is the B. Suppose here we are using some particular output is, suppose here we are using some particular output is C. So here it is 0, sorry, and this one is 0, and this one is 1, and this one is 1, and this one is 0. That time what happened? This one is also 1. Okay, and this one is also 1. So what happened? 0, 1 means what? If A equal to 0, suppose A bar equal to 0, and B is 1. And again, this particular sequence C, A is 1 and B bar equal to 0, because this one is the post from product of, sorry, sub from, sum of product from. So what happened? That time what happened? Output is 0. And otherwise what happened? All the outputs are, no, sorry, the output is 1. And the other sequence, the output is always provide 0. Okay. Now what happened? This is the operation of XOR gate. Okay. And XOR gate we are defining this way. And you can use anything here. If, suppose I am using here 2 input. So this is the XOR. See here, if using XOR gate or XOR operation with the help of 1, can we implement the NOT gate? Suppose here we are using, suppose variable A. Suppose the first input line we are considering variable A. And second input line we are considering the constant 1. This is the fix. You cannot write instead of, you cannot write 0 instead of 1. The 1 is the constant value, fixed value. Okay. That time what happened? this particular input, if we are applying this particular expression, that time what happen? See here, a bar dot 1, because b is here, we are considering as a 1. After that what happen? Yes. So what happen? Next one is what? Next one is 1. This one is a bar, b equal to 0. Are you getting my point? So what happen? How we can write a bar dot 1? So what happen here? B equal to 1. And when we are writing b bar, sorry, here a equal to this, a equal to b bar equal to, sorry, this one is not a complement. Suppose this one is a. Here it is some mistake. Okay, you don't consider it is the complement. Okay, this is not a complement. A dot 0. That time what happen? A dot 0 equal to what? It is 0. And a complement which multiply with 1 means what? We are getting a bar, not a complement. A complement plus 0 means what? It is a complement. So what happen if we are using, so this one is what? Always we are getting a complement. Okay, so with the help of XOR operation and constant value 1, if we are implementing NOT gate, that time what happen? N is already present, and we know n comma NOT gate is already functionally complete. So we can say that n comma XOR comma 1 is also functionally complete. If any doubt, then please ask me. If this particular expression you have any doubt, then please ask me. वहां पे है कि नहीं है, ये लोग पता नहीं क्या कर रहे हैं. 40 students, all the students are keep silence, and 2 and 3 students are telling something, and it is मुझे रेस्पॉन्स करना है किसी भी तरह, इसीलिए आप लोग मतलब रेस्पॉन्स कर रहे हैं, जस्ट फॉर्मेलिटीज कंप्लीट कर रहे हैं. बाकी स्टूडेंट कहाँ गया? Where is the other students? Okay, you are if you are getting everything is okay, then it is from my side, it is no problem. If you are understand, okay, it is very good from my side, because मुझे अच्छा लगेगा कि आप लोग समझ में आप लोग को आ रहा है, because without any question you are getting yes sir, it is okay, very good. So what happen? We already know that NOT gate and AND gate is functionally complete, so we can say that n comma XOR comma 1 is functionally complete. Now similarly what happen? Or XOR comma 1, because we know already XOR 1 is produce the NOT gate, and OR comma NOT gate is also already we have seen that OR comma, the combination of OR comma NOT gate is also called a functionally complete. That's why we can say that OR comma XOR comma 1 is functionally complete, and this is the proof. And when we are successfully implement the NOT gate, then OR gate is already present. NOT comma OR gate is already functionally complete. Okay, so what happened? Hence we can say that OR comma XOR comma 1 is functionally complete.
सर
बोलो, बाप रे बाप, बहुत देर के बाद क्वेश्चन आया है, बोलो. हाँ
ना सर, a complement into 1 plus a into 0 ना, not a.
see here. Here suppose what happened? Just you consider this particular a is this particular a. मैं जैसे कर्सर लेकर जा रहा हूँ उसी हिसाब से आप लोग देखिए, आपको समझ में आ जाएगा. रुकिए एक मिनट, जस्ट मिनट, मेरा बैटरी खत्म हो गया. Yes, see here, this one is a, and this particular one is b. Now just you can insert this particular form. So a means what? It is a bar. So here I am writing this one is the a bar. Okay. Next one is b. B value is what? 1. So here I am writing 1. Are you getting my point? Plus here what happens? This one is the a. So this no, it is not a complement. No, this ये complement नहीं है. मैं बोला था ना ये complement नहीं है. Just you remove कर दीजिए. ठीक है? तो इसमें क्या है, इसमें a है, तो इसमें a है, ठीक है, a है. Now see here b complement. So here what, b value is 1 and b complement value is what, 0. So b complement means what, this one is 0. Are you getting my point? A dot 0 means what, this one we are producing as a 0. And a complement with 1 means what, a complement and a complement dot 1 means what, it is the a complement. Dot means what, we are using the product term. A complement plus 0 means what, a complement. So what happened, with the help of XOR comma 1, we can produce the, this one is the a dash, sorry, a is what, the NOT gate is what, if the input is a, then output is a bar. So we can successfully generated the a complement. That means what, it is meaning is that with the help of XOR and one particular constant value, which value is 1, we can implement the NOT gate. And OR gate is already present. So OR comma NOT gate, it is already, we have checked that OR comma NOT is functionally complete. So OR comma XOR comma 1 is also functionally complete.
सर 1 ना वो उन लोगों ने असाइन करके ही दिया है ना, 1 कांस्टेंट ही लेगा, 1 ही लेगा उसमें को.
उन लोगों ने, किन लोगों ने?
1 जो हमने लिया है वो कांस्टेंट क्यों लिया है, हमने 1 ही क्यों लिया है?
1 इसीलिए लिया है कि 1 लेने से हम लोग का नॉट गेट होगा. अगर 1 के जगह तुम अगर 0 फिलअप करोगे यहाँ पे, ये नॉट गेट का क्राइटेरिया फुलफिल नहीं होगा. ठीक है. और क्यों नॉट गेट को क्यों हम लोगों ने लिया, क्यों हम लोगों ने पहले प्रूफ करके यहाँ पे प्रूफ करके देखा कि और नॉट गेट इज फंक्शनली कंप्लीट, और गेट तो यहाँ पे ऑलरेडी प्रेजेंट है. ठीक है. तो हम लोग को क्या निकालना है, नॉट गेट निकालना है. और 1 के जगह हम लोग 0 देंगे तो ये एक कॉम्प्लीमेंट कभी नहीं निकलेगा. इसलिए हम लोगों ने क्या किया, यहाँ पे मैं पहले जो बोला था ये फिक्स है, ये कांस्टेंट वैल्यू है, इसलिए मैं यहाँ पे क्या लिखा हूँ, कांस्टेंट वैल्यू 1. तो इसको इसीलिए लिया हूँ क्योंकि वो नॉट गेट हम लोग निकाल सके. और एक बार नॉट गेट निकाल लिया तो और कॉमा नॉट, ये पॉसिबल मैं देखा रहा हूँ, पॉसिबल कौन कौन सा कॉम्बिनेशन पॉसिबली फंक्शनली कंप्लीट हो सकता है. ठीक है. इसको 0 देंगे तो आप 0 में ये एक्सप्रेशन लिखिए, ये ए बार आपका नहीं निकलेगा. ठीक है. वो नॉट को फोर्सफुली निकालने के लिए हम लोगों ने 1 को यहाँ पे रखा. और नॉट को क्यों निकाला, बिकॉज वी हैव ऑलरेडी प्रूव दैट और कॉमा नॉट गेट इज फंक्शनली कंप्लीट. समझ में आया?
हाँ
समझ में आया, पूरा बढ़िया से आया तो?
हाँ आ गया.
हाँ, ब्रेकफास्ट कर लिया ना तुमने?
हाँ कर लिया था.
थैंक यू, वेरी गुड. और किसी का कोई डाउट है?
No,
आज तक एक भी लड़की ने मेरे को क्वेश्चन नहीं पूछा.
No, sir.
ओके, गर्ल्स आर देयर, गर्ल्स आर देयर.
Yes, sir.
You are getting or not? You are
Yes,
getting
sir.
or not?
Yes, sir.
Okay, you are, it is not like that. Na, you active the slide and after that you are going somewhere. You can constantly sitting with me or not? No answer. Again, you are not replying anything.
Yes,
आप
sir.
लोग
Yes, sir.
हाँ.
Yes, sir. Constantly sitting with you.
Yes, sir. We are here.
Okay, so what happened? So just you remember this particular bit, because when you are designing the circuit, these particular things are very important. Okay, so what is the summary of this particular whatever we are discussing? The first point is that NOT and OR gates are basic gates. Okay, and so it is basic gates. So also we can say that NOT, the set of NOT and OR gate is also functionally complete. Now what happens, if any other gate, we have to prove that particular gate or gates, that particular gates are functionally, the combination of gates are functionally complete or not. That time what happens, we can implement NOT gate, AND gate and OR gate, because NOT gate, AND gate, OR gate are basic gates. Okay, if successfully we can implement NOT gate also, AND gate also, and as well as OR gate also, that time we can say that that particular gate is functionally complete. So here NAND gate successfully.
Sir, is it compulsory to that the gate should realize by NOT and or all three compulsorily?
No, it is not realized. It is depend upon to the Boolean function. Okay. Suppose what happen, see, you can design all the circuits. You can design AND gate, OR gate, and NOT gate. No problem.
Yes,
You can design. Then why people are introducing NAND gate, NOR gate? Because what happen, if we are using the AND gate, that time what happen, many number of AND gates you are using. Okay, and your expression is very lengthy. Okay,
yes, sir.
so that time what happen, instead of we are using two NOT gate and two AND gate, that time what happen, we can remove that one and directly we can put the NAND gate also, or whatever, the NOR gate. Okay, so what
Okay,
happen,
sir.
so that is why this particular minimized boolean expression is required. ओके नहीं तो हम लोग क्या करेंगे, एक एक्सप्रेशन लिखेंगे, कोई रूल वगैरह कुछ भी यूज नहीं करके, जितना भी एक्सप्रेशन लेंगे उसी हिसाब से हम लोग सर्किट बनाएंगे. तो सर्किट क्या होगा, सर्किट का साइज बहुत बड़ा हो जाएगा. और एक सिंपल सा एक सिंपल आउटपुट निकालने के लिए, आउटपुट निकालने के लिए आपको 10 तो एंड गेट जरूरत पड़ेगा, 10 तो नॉट गेट जरूरत पड़ेगा. तो उसको कैसे मिनिमाइज करेंगे, बेस्ड ऑन द एक्सप्रेशन. सो sometimes what happen, using the AND or NOT gate, it is better. Sometimes we are using the NAND gate, or it is very because it is easy. Some particular situation it is easy. So what happen, people are using the some alternative gates, and this is not a unimportant alternative gates. This is very important gates, NAND gate, NOR gate, whatever the gates we are using. Okay.
Yes, sir.
And also NOR is also functionally complete, because also we can implement NOR gate, AND gate, and OR gate. And the combination of AND comma NOT is also functionally complete. Are you getting my point? And OR comma NOT is also functionally complete.
नेक्स्ट स्टेप क्या बना, z की वैल्यू पुट कर दी, u प्लस एट का भी लेफ्ट में बना sin x और sin
Okay.
y plus
Okay.
i
Now, and n comma xor comma 1 is also functionally complete. Okay. So no doubt, not here.
देता हूं अगर चाहे तो आप.
Someone open the audio. Okay. ये एक ही टाइम में एक ही काम कीजिए. ठीक है, 2-3 ऑडियो खोल के रखने की कोई जरूरत नहीं. ये बोल लीजिए किसका ऑडियो ऑन है, माइक्रोफोन ऑन है किसका. n comma xor comma 1 is functionally complete. And also OR comma XOR comma 1 is also functionally complete. Now, though we are not discussing the multiplexer, demultiplexer, because we are going to discuss, but you remember one thing, 2 into 1 marks, comma 0 comma 1. So here we are using two constant value, 1 is 0 and 1 is 1. And what is marks and what type of things we'll discuss later. Okay, just you, for the time being, you just remember 2 into 1 marks. That means what? 2 inputs are there and 1 outputs are generated. So it is called 2 into 1 marks. When we are combining 2 into 1 marks with the constant value 0 and 1, this one is also a functionally complete. Okay. See how we are using the how we are using 2 into 1 marks is a functionally complete. Suppose what is the 2 into 1 marks? So here A and B is called input lines, and F is the generated output lines, and here S, this one is S. Okay, S means what? It is called a selection line. Based on the selection, we are taking the input, and from that particular input, the output is generated. That is the meaning of marks. Okay, more details when we are going to the combination circuit, then we will discuss details about the marks. For the time being, how we can use the 2 into 1 marks. Okay, see here the function, if we are using ABS, suppose for even we are using these particular three variables, A, B, and S, where A and B are the input lines and S is the selection line. Are you getting my point? So see here, always remember when S equal to 0, that time what happened? This particular A line is selected and it is propagated to the F. Okay, and when S equal to 1, that time what happened? This particular second line, that means S equal to 1, that means B line is propagated to the F. Okay, that is the meaning. So here I am writing S equal to 0 means what? We have F equal to A, and S equal to 1 means what? We have F equal to B. And what happened? So see here, so when S bar means what? When we are, this is the what? This is the short form, sum of product. And you know, when we are considering the sum of product, that means complement means what? 0, and uncomplement means what? 1. So S bar means what? When it is 0, when S equal to 0, that means S bar equal to 0, the A line is active. It is not like that A dot A into 0. A into 0 means it is something different 0. Just you remember that when we are using S dot 0, that time what when this one is A. And when, oh, here again I am writing some particular problem. Here, just you don't use the complement here. And when we are using the S equal to 1, that time what happened? This one is B. B is selected. So this particular expression we can write this way. So A dot S bar plus B dot S. Okay. Now what happened? If we are using 2 into 1 marks with the help of 0, 1, then can we implement the NOT gate? Or can we implement the AND gate? Anyhow, if we are proving NOT gate and as well as AND gate, that time what happened? This combination 2 into 1 marks, 0, 1 is functionally complete, because we know that already we have proved that NOT and the AND gate is already functionally complete. So that's why 2 into 1 marks, 0, 1 is functionally complete. So how we can implement the NOT complement? See here, if we are using marks here, it is 2 into 1. Suppose just we are writing 21. Suppose 21 means what? 2 into 1. Okay. Suppose marks 2 into 1, there are 3 inputs we are considering. Suppose here 1 is what? A is 1, B is 0, and S is A. Okay. So A means what? Here A dot S bar, A is 1, and S bar means what? It is A bar. So here I am writing 1 dot A bar. Next, A means what? B. B means what? It is 0. So here I am writing 0. This one I am writing 0. Okay, 0, 0. And after that, what happened? Next one is S. S means what? A. So here it is A. So 0 dot A means what? 0. And 1 dot A bar means what? This is the A complement. So we can successfully implement the NOT gate. But single NOT gate is not a functionally complete. We can either include OR gate, we can include AND gate. But this particular combination, we can easily prove the AND operation, not a OR operation. See here again, same concept. If we are applying A, 0, B bar, that time when this particular expression is coming based on this particular expression. Okay, and after that what happened? Here 0 dot B complement means what? 0, and this one is AB. So we are implementing AND gate, so A dot B is coming. So we can successfully, with the help of 2 into 1 marks, 0, 1, we can successfully implement the AND gate. And we know NOT gate and AND gate, the combination of NOT gate and AND gate is the functionally complete. So we can say that 2 into 1 marks, 0, 1 is also functionally complete. Any doubt?
Sir?
No,
Yes.
sir.
Yes.
सर नॉट में जो हम 1, 0, A क्यों लिया?
तुमको मैं पहले बता चुका हूँ वो।
सर वो तो है
1, ठीक है 1, सपोज मुझे मार्क्स का जो नॉर्मल इक्वेशन है, वो मेरे को पता है। स्टैंडर्ड इक्वेशन क्या है? मैं अगर 3 वेरिएबल लूंगा उसमें से क्या होगा, मेरा सिलेक्शन द कॉम्बिनेशन ऑफ इनपुट लाइन एंड सिलेक्शन लाइन एक से भी ज्यादा हो सकता है, बट हम लोगों ने क्या किया है, ओनली 2 into 1 मार्क्स लिया है। ओके, सो 2 to the power 1 ऐसे लिखते हैं हम लोग, 2 to the power 1, 2 to the power 1, ये जो 1 है ना, इसको हम लोग सिलेक्शन लाइन में यूज करते हैं। अगर 4 into 1 मार्क्स होगा तो कितना होगा, मेरा सिलेक्शन लाइन 2 होगा, बिकॉज 2 to the power 2 मीन्स व्हाट, इक्वल टू 4। Are you getting my? That particular part we'll discuss later. Okay, so ये इसमें 4 into 1 marks में 2 सिलेक्शन लाइन होगा, but 2 into 1 marks में कितना सिलेक्शन लाइन होगा, 2 to the power 1 equal to 2, so इसमें 1 सिलेक्शन लाइन होगा, इसीलिए हम लोगों ने यहाँ पे S को सिलेक्शन लाइन दिया। और because this is the 2 into 1 marks, so 2 input lines are there, we are considering this one is the A input and this one is the B input. And this particular 2 input and the selection line, if you are include in the marks 21 or 2 into 1, sorry, not a 21, marks 2 into 1, that time what happened, what is the output? Output is A S bar plus BS, है ना, B dot, you can use dot and S, and here also we are using dot S. Now हम लोगों ने खुद करके देखा 2 into 1 मार्क्स के साथ क्या जोड़ने से नॉट गेट होगा। जो तुम्हारा क्वेश्चन है उस क्वेश्चन का आंसर वही है, ठीक है। तो हम लोगों ने क्या किया, 0 और 1 को, क्योंकि सिर्फ 0 लेने से नहीं होगा, 0 और 1 को लेना पड़ेगा, क्योंकि यहाँ पे इसीलिए मैं कांस्टेंट वैल्यू क्या रखा, एक 0 रखा और एक 1 रखा। तो इस पर्टिकुलर एक्सप्रेशन को किस टाइप से मुझे क्या वैल्यू देने से मुझे ए कॉम्प्लीमेंट आएगा। ए कॉम्प्लीमेंट मीन्स व्हाट, मेरा अगर नॉट गेट मेरा इनपुट ए है तो मैं उसको ए नॉट गेट का कॉम्प्लीमेंट लूंगा तो क्या होगा, ए कॉम्प्लीमेंट आएगा, ठीक है। तो मुझे ऐसा कोई सीक्वेंस देखना है जिस सीक्वेंस से मेरे को ए कॉम्प्लीमेंट आए। ओके, सो मैं क्या लिया, इसके लिए मैं क्या किया, मार्क्स में मैं ये सीक्वेंस अप्लाई किया। अभी तुम पूछोगे 1, 0, A, इसको कौन सा सीक्वेंस में लिखा हूं, मैं इस सीक्वेंस में लिखा हूं, ABS। सो पहले वाला 2 सीक्वेंस क्या है, इनपुट सीक्वेंस है, और ए यहाँ पे क्या है, यहाँ पे सिलेक्शन लाइन, ये कॉम्प्लीमेंट नहीं है, सॉरी सिलेक्शन लाइन। कौन सा सिलेक्शन लाइन, ये वाला मार्क्स का सिलेक्शन लाइन, ठीक है। तो इसमें क्या दिया, A डॉट S बार, सो S मीन्स व्हाट हियर, S मीन्स A कॉम्प्लीमेंट। Are getting my point? So
Yes,
उसमें
sir.
क्या दिया, A का क्या वैल्यू दिया, यहाँ पे 1 इक्वल टू A, मैं जैसे दिया 1 इक्वल टू A इज कंसीडरिंग A, और जो S का क्या है, सिलेक्शन लाइन क्या है, यहाँ पे S है, तो इसमें क्या है, S बार मीन्स व्हाट, S का वैल्यू यहाँ पे क्या है, A है, सो यहाँ पे मैं क्या किया, कॉम्प्लीमेंट लिया, बिकॉज हियर दिस वन इज द S कॉम्प्लीमेंट। ओके, तो मैं यहाँ पे कॉम्प्लीमेंट लिया। नेक्स्ट इज फॉर B, so B already, we can say that B is already 0, so here it is 0 and only S is there, so S equal to A, so we are getting A complement. So you can find out which using the 2 into 1 marks when we are using 0,1 sequentially, not a 1,0, 0,1. If I'm writing, I'm deciding this one is because here we cannot write B input line and after that A is coming. We are going in sequence manner, A and after that B. So here I'm writing 0,1. So what happen? If we are using 0,1 into 2 into 1 marks, that time what happen? We can successfully produce the NOT gate. That is why मैंने यहाँ पे 0,1 लिया, ठीक है। और ये 0,1 नॉट गेट का भी करते हैं और एन गेट का भी सक्सेसफुली करते हैं। अभी एन गेट के क्या करेंगे, एन गेट के लिए मैंने ये सीक्वेंस लिया। अभी इसमें क्या हो गया, मेरा ए क्या हो गया, ए पहले 1 था नॉट गेट में, यहाँ पे एन गेट में क्या हो गया, ए का वैल्यू यही है, बी का वैल्यू क्या रख दिया मैंने, यहाँ पे 0 रख दिया, और एस का वैल्यू इंस्टेड ऑफ ए में एन गेट के लिए क्या किया, एस का वैल्यू में बी कॉम्प्लीमेंट रखा, और सेम फॉर्मूला में, ये पार्टिकुलर फॉर्मूला में मैंने इसको put कर दिया. When we are putting and when we are inserting the value of this particular expression, that time what happen? A dot B, and A dot B is nothing a AND gate.
Sir, we have a scheduled maths class now, and sir is waiting for the class.
Okay. Then this is my last class. So why you are not telling? Because my screen is the full screen. I am not checking the time and all those things.
Yes.
Okay,
sir,
so that is why.
just now gave the link.
Okay, so why not an AND gate? Because we cannot prove not an OR gate, because 2 into 1 marks, 0,1 we cannot prove not an OR gate. Okay, but we can successfully prove not an AND gate, and already we know that non-AND AND gate is the functionally complete. So we can say that 2 into 1 marks, 0,1 is the functionally complete. Okay, which sir is waiting for you?
Pradeep sir, maths sir.
Okay.
Pradeep sir.
Okay, just you leave one by one.